it's a portable radio, as you can tell. Now, one of the reasons why I bought this particular radio is because it's a 70s model. Okay, so I don't know the exact year it was produced, but I'll look it up. In any case, it is a 70s model, and I like 70s design very much so. So that's one of the reasons why I bought this radio. It's a cute little radio, and it looks to be complete. So there are no knobs missing, and I even got the AC cable for it. And one of the parts that often lack in these portable radios, which is the battery bay door, well, it's present here on the radio. So yeah, I think the radio, as far as external parts are concerned, is complete. Now, does it work? No idea. The seller did not mention whether it worked or not. The only thing he said was that it was complete. Right. I took off the slide button for the volume, and for the tuning, the rotary knob, off the top of the radio. Okay, so you see here the slide, the volume slider, yeah, potentiometer, and of the tuning knob, yeah. So I took off those two knobs, and I also proceeded by pulling away the bay door for the battery compartment, and it actually slides to the left. Okay, so like the little arrow on the bay door indicates, it should slide that way. Now, it was pretty hard to slide, so I had to exert quite a bit of gentle force on it to make it actually slide in the opposite position. I didn't want to use any sort of screwdriver or whatever to force it, because it's plastic and I really don't want to leave any marks on it. Okay, so I did that, and I investigated the battery contacts, and aside from a little piece of foam which you see there, which is probably factory, I see no corrosion, absolutely none. So the battery contacts are really as nice and as clean as when the radio came out of the factory, which means this radio has probably been used on AC power for its lifetime. Okay, so here you see the model number, which I told you, which is the Derby 7652450. It's German, obviously, but whether it was produced in Eastern or Western Germany, I can't tell. Maybe some of you are able to tell me whether this radio model was actually produced in Eastern or Western Germany, but my guess is this was produced in Western Germany, probably. Okay, there's also a little mystery knob here on top, this one, and when I rotate it, it just keeps on rotating. It never stops. So it can't be a potentiometer, so it has to be something else. So I'm rather curious to find out what it is. Right, now to open up the radio, what I did was, so I took off the knobs, those two knobs you see over there, and I also took out the 4 corner screws which go on top of the tuning panel, yeah, on the front bezel, you could say, of the radio, or the top bezel. There were actually 3 more screws to undo, one on each side at the bottom, so one here, one here, and then one at the bottom here. Okay, so I undid those 3 screws as well. Now, judging by the state of the screws, I am tempted to say that somebody has been inside the radio before me. Okay, so who knows what we're going to find inside the radio. Hopefully not a mess, but it seems to me that somebody has been inside the radio before for whatever reason. So let's find out what that reason might be. Okay, I managed to release the tuning dial from the top of the radio. Okay, so what I did actually was I slid my nails, my fingernails, and I really don't have that large nails, under one edge of the tuning dial and lifted it gently. Now it appears that it was stuck with a kind of, well, tape, I would say, to the top of the radio. Okay, so, and you still see the traces of the tape here. Okay, so all over its length it was stuck to the top of the radio, and the glue held pretty fast, so I had to work my fingernails all around the dial plate and slowly and gently work it loose, which took me about a minute or so, or maybe 2. But there you go, I managed. Now, there are 2 details I immediately noticed. First of all, the mysterious knob here is actually the top of a small variable capacitor, which you see down there. So my guess is this mystery knob here is a kind of a fine-tuning feature. Okay, and the capacitor itself looks pretty dirty, so I'll have to clean it out for sure. Now the chassis inside the radio hasn't budged at all. Okay, so despite having released all the screws, I can't seem to get it moving. Now at first I thought that maybe the chassis would be held in place by the carrying handle, yeah, on both sides, but it appears not to be thus. If you look inside, you see the carrying handle is actually attached to the cabinet, but not at all to the chassis on either side. Okay, so yeah, well, then how do we get it out? Well, my guess is I need to push the chassis out from the bottom of this cabinet, but it's pretty stiff. Yeah, I don't know what's holding it in place yet, and I don't want to force it. Now the reason why I'm saying that it probably comes out the bottom of the cabinet is because you can see the corners of the chassis are wider than the corners of the cabinet. So that's one clue. The other clue is this cutout here, and that cutout seems to fit right around the pin of the carrying handle. So yeah, my guess is the chassis needs to be pushed out the bottom. Now, how to release? I found it. Okay, so it turns out the chassis is held into the cabinet via two rails. And you see the rails there. I'll point it to you. I'll point it out to you. So you see one rail right here. Okay. And you see another rail down here. Okay. So right here, where I'm pointing at here. Now, the trick to release the chassis from the cabinet is actually you need to push with your thumb on both sides of the chassis. So here and here, while holding the cabinet in your hand. So like this actually. Okay, and on both sides. So you need to exert pressure on both sides at once. If you do that, the radio releases. So let's see, or I should say the chassis releases. So here we go. There you go. And you can see the chassis appearing at the bottom. Okay, so hang on, because I'm doing this with one hand. Here it comes. Okie dokie. So that's the inside of the cabinet. Right, and you see at the top over there, you see the rails I'm talking about. So right here. Okay. So anyway, this is the chassis. Well, I can't tell, I can't say I see a lot. Ooh, this is going to make my life a misery. You see this? So this is the PCB on which all the parts are soldered. And for some reason, this piece of, well, I wouldn't say it's cardboard, but no, it's more like a kind of foam perhaps, was glued to the PCB. You can actually see the glue here. Okay, so that's going to make my life a misery, especially since they glued part of it over very, very thin wires you see running here. Okay, so yeah, that's going to make my life generally miserable. Okay, well, fine, it is what it is. Let's turn it over gently. It's actually not very heavy, the chassis. Okay, and here are the parts. And right away, I see something suspicious. Okay. I see that this capacitor here looks, well, dirty. It might not be good. It's an electrolytic, by the way, so I see several electrolytics in here. So there's a big one here. Okay, actually there are several big ones there. So this is probably a 1000 microfarad. And these are probably 100 microfarad, these two. But size isn't everything, so they might as well be smaller capacitors, but it's hard to tell. Now, one thing I notice immediately is that the inside of the chassis is really, really compact. Yeah, so they really stuck in the parts extremely closely to each other, which will make my life a bit of misery. I can see right away a few transistors, so I see one here poking its head out here. I see this is probably one of the diodes here. But it's so darn compact that it's pretty hard to say whether I'll be even able at all, if I need to change replace any parts. Well, I don't know if I'll manage. Before the battery ran out, I was talking about the end stage transistors, so these two here. And these are the amplification transistors, obviously a kind of push-pull setup, and they are mounted in a very basic heatsink, which is actually nothing more than a folded piece of metal foil. Yeah, so I guess those must be the two OC74s mentioned on the schematic, so these two here. Okay, so, and those are OC74. By the way, all the transistors in the radio are PNP type transistors. Okay, so anyway, yeah, well, at first glance I would tend to say that I don't see anything suspicious, except perhaps for a little bit of dirt on this electrolytic right here. But aside from that, I don't see anything burned or ripped or broken. So my guess is somebody probably tried to open up the radio to have a look inside for whatever reason and didn't succeed. Okay, so, and decided probably that it wasn't worth the effort to open it up, which makes me kind of apprehensive, because it's possible the radio doesn't work at all. Now, this is the tuning mechanism, and look at how complicated this setup is. I mean, you have a little wire here, okay, running all the way around this pulley, then let me see, then running up here, okay, then running along the top right down the length of the top bezel, then back, then down this tiny little pulley here and around this one, and then back up again to this wheel. So yeah, well, that's really rather complicated, and it also runs around this little knob here, yeah, which obviously turns that pulley, which in turn has a gear at the back, okay, a gear you see over there. Let me take my pointer because my finger is a big fat. So you have a gear right here which actions this big gear, which in turn actions this variable capacitor here, so for the tuning, obviously. Now okay, well, I can't see any obvious faults in the chassis. So, well, I'd be tempted to do a little Shango here and just connect it up to the AC and switch it on and see what happens. Now, I did do one thing off camera, and that was to measure these two fuses you see here. So this one here and that one there. It says secondary 315 milliamps. So for whatever reason they decided to put two fuses on the secondary rather than one. Although I suspect one is on the battery circuit and the other is on the built-in power supply. In any case, I connected up the AC to the radio, and I'll set the volume to about a little bit less than medium, like this, and I'll push the button for FM, which is this. Now let's see whether the antenna is okay. Ooh, it's a bit stiff. The radio could do with some cleaning, you know, because everything is really stiff. The antenna is, the volume knob, the selector knobs, the tuning, everything is stiff with dirt. Okay, well, this is FM. Well, okay, here we go. Well, it does seem to work. Ooh, there's a very bad buzz. There's very bad buzz in the radio, and the sound is distorted. So yeah, the sound is distorted. And when I'm not on a specific channel, there's a buzz in the sound. So I would be tempted to say that there probably is a problem. There is probably a problem with the power supply. Okay, well, that sort of directs us in a specific direction. So, well, the next thing is to uncover the power supply, which is down here behind the speaker. So this necessitates for me to release the speaker, and as you can tell, yeah, if I take the pointer, there are 3 screws. So one here, one over there, and one here. So I need to release the speaker, which by the way looks really fine, no damage whatsoever, and it moves freely. It doesn't sound scratchy when I move it back and forth. So the distortion in the sound is certainly not from the speaker. Okay, I have mounted the speaker from the chassis. Okay, it's dangling here by 2 tiny wires, a white and a red one, which are actually going to the earphone jack. and I can tell immediately it's mono, obviously. Now anyway, down here you see the transformer, power transformer, okay, right there. That's the power transformer, and the lines of the power transformer go to the back of the fuse holder. Yeah, and the fuse holder is that little white thing you see over there. Okay, so I'm pointing at it. So this here is the fuse holder, and then from the fuse holder the power lines, the AC power lines, go to the PCB here, to these tabs you see here. Right, so in any case, something must not be right with the power supply. So I think what I best do next is maybe put the scope on the output of the diodes. Alright, I replaced the 4 capacitors which were built around the output stage of the radio, and also to filter out any ripple on the power supply. Actually, this one was bridging the output of the power supply. These 3, on the other hand, were all built around the final stage, or the output stage of the radio, and now it sounds a lot better. So yeah, there's less buzzing in the noise. In fact, there isn't any buzzing in the sound anymore. However, the radio as it is can't really handle very well very deep bass sounds. So when the music is playing very loud, very deep bass sounds, it really starts to distort quite a bit. Also, I can play really loud, but then of course the sound is completely distorted. But I can go really, really loud. Watch this. So yeah, really loud. Okay, so I think this fixed the problem of the buzzing noise in the radio. And although I didn't have a schematic, I think, well, in the end it turned out okay, because I used common sense. I guess by having a peek at the schematic I had, although it isn't exactly the right one, I sort of thought my way through it and well, managed to find the fault. Now, to replace at least this one here, and if I'm not mistaken this one, yeah, I had to release the amplification stage, yeah, of the radio. And the way to do that was to unscrew a tiny screw which was attached here to the heatsink, okay, and that screw came out through this little slit here in the plastic of the chassis, yeah, in the body of the chassis. So I had to release that little screw, and I had to cut through a lot of glue, or well, something that looks like glue, to release this. I had also to be gentle doing it, because those yellow leads you see over there are the leads that go to the end stage transistors, and you really don't want to break those. So now that I replaced all the capacitors down there, so here there are a couple, yeah, so this one here and then that one there. Now that I replaced those two, I can safely remount the heatsink, and well, as far as replacing parts goes, well, this is it. I'm mounting back the speaker. Now, the more observant among you might have noticed that I in fact replaced the original wires that ran to the speaker, and the reason why is because I wanted to be able to service the speaker without having the wires stretched to the extreme, and it worked out pretty well. So now I'm going to mount back the speaker. Now originally the speaker came with little rubber mounts like these on which the speaker rests. I suppose that is to reduce any vibration in the speaker, but I kind of doubt it helps. But since they were there originally, well, I'm going to place them back. I mean, it can't hurt to have them there, so that's exactly what I'm doing. Okay, so there are only 3 screws actually holding down the speaker, and the speaker is actually mounted. There is this little tab you see here, okay, and the edge of the speaker is clamped inside that little tab, so that's exactly what I'm going to do. I'm going to clamp it inside and then center the holes for the speaker over the other holes. Hang on, I dropped the screws. Okay, there you go. I have the screws. Okay, so now let's screw back the whole thing. And since it's still rather fresh in my mind, I know more or less in which order to put back the screws. So, hang on. Okay. So, here we go. I hope you can see what I'm doing, but okay, I'm not going to tighten them completely just yet, at least not until I got all the screws in correctly and have the little rubber mounts. Now, originally there was this little eyelet here. I don't know if you can see it, but this little eyelet here, yeah, which was attached to the speaker. It's a kind of a grounding, I would say, but what its exact function is kind of a mystery to me, because the other end of this capacitor, which you see here, so this capacitor, the other end is attached to the metal case of one of the band switches. So whether that's a kind of a grounding or something like that, I don't know. What its exact function is, I don't know. I really have no clue what they would want to achieve with this capacitor, but, or well, this grounding, so to speak. I don't know. It's a filtering of some sort, no doubt, but what they want to filter out with it, well, that's kind of a mystery to me. And since I don't have the right schematic to the radio, I'm afraid, until next time at least, I'll be due an answer to you. Until, that is, I can find out what the exact function of that one capacitor is. Now anyway, I don't think it can play such a big role in the functioning of the end stage of the radio, but well, that's it. The speaker is attached fast. I cleaned all the buttons, and I also lubed the tuning pin here, yeah, and now it turns a lot easier, yeah. So before it was extremely hard to turn around. Now it's really easy to turn, and mind you, that's without the knob. So with the knob, it'll probably be a lot easier as well. It would seem that I got a bit over enthusiastic when I said the radio was done. Actually, it turns out the radio is not done, and in fact the problem lies with the other bands the radio can receive. So we tested the radio only on FM band, which is this. By the way, the Germans say UKW, which stands for Ultra Kurze Welle. Yeah, okay. Then you have the shortwave, yeah, which the Germans say as KW, Kurze Welle. Then you have the AM band or broadcast band, yeah, which is shortened to MW, Mittelwelle. And then you have the long wave band, yeah, which is in German LW or Lange Welle. Okay, so we didn't check these three, and it turns out the radio doesn't seem to work in either of them. Now we know that the amplification stage works, and the power supply bit, so that would be around about here, okay, and we also know the FM band works, so I'm pretty certain the well, that the IF stages and the decoder stage for FM are okay. So that seems to concentrate our problem on the IF stages of the AM band. Now, where would those be? That's a very good question. Now, let's have a look at the part side. So, you know, all of the IF stages seem to be either at the bottom of the PCB, right here, yeah, or to be at the top here, yeah, or well, rather in the middle of the PCB. Which is the FM and which is the AM band? I don't rightly know, but what I propose to do is to inject a low frequency signal, and when I say low frequency, I would say somewhere in the hundreds of kilohertz, at each stage, each IF stage, until we get a say decoded AM signal. So because the AM will be modulated with a low frequency sound, okay, so around about 400 hertz. So I will inject at several spots a high frequency signal, and that way I hope to find out at which particular time the radio stops working. Okay, so yeah, well, what I also could do, of course, is measure with the scope and see whether I get a sort of IF signal, yeah, to see whether the local oscillator works. Now, I seem to see a small coil. Hang on, let me take a pointer here. Okay, so I seem to see a small coil right here, and that I would think would be the coil for the local oscillator. Whether it's the FM or AM local oscillator, I don't know just yet, but we'll see. And there are two more coils here. They are capped in a kind of plastic. So I would tend to think this is the second local oscillator. Again, either for FM or AM. So in fact, there are two things that I would need to do. First of all, see whether the local oscillator works. And secondly, whether the IF stages work. Alright, I finally managed to lay my hands on the right schematic for this particular model of Blaupunkt Derby portable radio. And at the end of the video, just look at the info beneath the video, and I'll add the name of the kind donator of the schematic. Actually, it's not just the schematic, it's also the service manual, because I don't only have the schematic but also the PCB layout with the parts, and by the way, how to thread the pointer, the dial pointer, but also the alignment procedures for the radio. Okay, you remember in my last assessment that I said, and I was pretty confident of that the output stage of the radio was working just fine. And any novice would, if any novice read the schematic, he would immediately see that this part here is the output stage, okay, so the amplifier stage, if you wish, simply by seeing this little speaker symbol right here. Okay, so anyway, you remember we replaced this capacitor right here. By the way, the output stage is consists of two PNP transistors, which are driven via the secondaries. So there are two secondaries on of a small audio transformer. I'll show it to you in a minute. It's really a tiny little transformer, okay? And that in turn, that transformer is driven via its primary by a driver transistor, which is this one right here. Okay, coincidentally, this is also a PNP transistor, and that in turn is driven via a preamplifier transistor, which is this one right here, also PNP. Okay, so we do know that the whole output stage works just fine. Okay, so in fact it works so well I can even overdrive the speaker, right? So and of course by corollary we can say that the power supply, which is represented by this part here, also works just fine. And you remember we also replaced this 470 microfarad capacitor right here. Okay, so yeah, I think it's safe to say that this whole section right here works just fine. Then we also know that the FM part, even though it doesn't work perfectly as yet, does work. Yeah, you'll remember we listened to a few FM radio stations. So if you look at the high frequency stage of the radio, I'll show you. Okay, so the whole FM section of the radio is this part right up here, from left to right. Okay, so let me pan the camera. So all the way up to here and all the way back is the FM section. Okay, so this whole band here is mainly the FM section. Anything below that is the AM, the long wave, and the shortwave band. So this whole section right here, yeah, including this part right here, right about here, is the lower frequencies section. Okay, right. So I also said, well, that probably the easiest thing to do first is to see whether the local oscillators work, either for the FM or the other bands. So I am going to measure, or I will show you what I measure exactly when I use my scope probe, which you see here. Okay, so with this scope probe, and thanks to the schematic, we can have a look at the local oscillators working for either frequency band. Okay, so for the FM, the long wave, medium wave, and short wave. Right. So what I'm going to do actually, okay, is if you look at the schematic, let me see if I can give you a close-up. Okay, so what I'm going to do actually is with the probe I'm going to measure at this point here, which by the way is marked by a symbol 4, okay, which is the emitter of transistor V2, which is by the way an NPN of the type 2SC1047. Excuse me. A totally unknown type to me, but no doubt high frequency NPN transistor. Right, so we're going to measure at the emitter of this transistor here. And then if you look down on the schematic, you'll see that this little section right here, okay, is for the shortwave, which by the way is indicated by the K. Okay, so in German, shortwave is kurze Welle, okay, KW, or in ultra short hand K, just K. And we're going to measure at the emitter of transistor V4, which is this one here, also an NPN. This though is a different type. It's a 2SC829. And then we're going to measure the signal at the very last transistor, which is this one, which is V3. Okay, and V3 just happens to be the same type as V4 down here. So also an NPN 2SC829. Also at the emitter, obviously, and at point 3. Okay, so practically what am I going to do? I'm going to press the selector switch, the band switch, for each of the bands, and then I'm going to measure at the emitters of the right transistors the signal we get, and we should get a local oscillator signal. Alright, so the very first thing we want to measure is the Fm Local Oscillator, and I already pressed the FM button or the band switch for FM, which is this one. And the only thing I'm going to do is switch the radio on by pressing on this button, and then we're going to measure exactly at this point here. And you remember I told you that's point 4 over there on the schematic, right? So right there, okay, so at the emitter of transistor 2, and that happens to be on the schematic that point over there. Okay, so and that point in really is this point right here. Okay, so that's what we're going to do, and while I'm holding my probe to that point, I'm going to turn the tuning knob here, or the tuning shaft really, and you're going to see the frequency of the local oscillator change. Okay, so let's just have a look. Okay, here we go. Okie dokie. Right, there you have the signal. Okay, now I'm turning the knob to change the frequency. And if you'll observe, hang on, You see the frequency changing? Okay, so I think you're all convinced that the local oscillator for FM works. Okay, now let's do the same thing for the shortwave band. Right, the shortwave band is this button here. Yeah, the contacts are still a bit dirty, so I'll have to clean those. So this is the shortwave band switch, right? And the next point we're going to measure is, let me think, is that one over there, the emitter of transistor 4, so V4, and a V4 is, let me see, is that right there? Okay, right there. And on the radio's PCB, that is this contact right here. Okay, so let me set up the camera so you can see what I'm seeing. Okay, so here we go. I am measuring right now. Okay, so there's the shortwave band local oscillator. And I'm tuning now. Hang on. Yeah. Okay. Wait. And you can see the frequency changing as I'm tuning through the whole shortwave band. Alright, so that's one end of the shortwave band. Now I'm going back to the other end. Okay, so that's the other end of the shortwave band. So the local oscillator for the shortwave band works perfectly, just like the one for FM. So what I'm going to measure now is the AM band, or the broadcast band, which is this switch here. Again, the contacts of the switch are very dirty. Okay, so this is AM, this is long wave. Okay, so we're going to measure either one, and well, let's just select the AM. Okay, and AM on the schematic, I'm going to measure right here at point 3, right here, the emitter of transistor V3. Okay, and that happens to be on the schematic right here. Okay, so let me show you on the PCB itself. So that would be this point right here, right here. Okay, so let me set up the camera so you can see what happens when I measure at that point. Okay, making contact now. Well, I'm sure you'll agree that there ain't much happening there. In fact, there's nothing happening at all. Okay, I mean really nothing at all. So what I'm surmising is that probably the transistor is transistor V3 is broken. Okay, so what I'm going to do next, I'm almost at the other end of the band, so nothing is happening. So what I'm going to do next is I'm going to measure the voltages at the pins of V3 just to have a look what's happening around that transistor. Okay, so on the schematic, let me give you a close-up of the schematic. So we're looking at this part right up here, okay? So let me just hold it a little bit closer. So what we're going to do is measure of around this transistor here, V3. We're going to measure the voltages at the base, the emitter, and the collector. Well, actually, the collector doesn't have any voltage marked, and really that isn't that important. What is important is this voltage right here at the emitter, which should be 3.2 volts, and the base should be 1.8 volts, or very close to those voltages. If, of course, the switch for AM is switched on, which I did. I did switch on the AM band switch, or I pressed it in rather. So let's go to the other schematic, which is this one. And you remember that V3 is this transistor right here, okay? So I don't know if you can see that, but okay, so this is V3, yeah? And we need to measure the voltage at the base, which is this point here, and at the emitter, which is this point here. And this should be 3.2 volts, I think. Let me see. Yeah, this should be 3.2 volts, and this should be 1.8 volts. Alright, well, let's see what kind of voltages we get. Okay, so the AM switch is on, the radio is on, so I'm on DC volts. Okay, now I'm on DC volts. I hope you can see it all. Okay, so I'm making contact with mass, and now let's see, the emitter is right here, right here. Oh, this is not so good. Minus 5.6. Hang on. Am I doing this correctly? Let me see. Just a quick check. Yeah, okay, that's the voltage of the power supply. At least one side of it. Okay, so right, so I think this is not very correct. Minus 5 volts, 5.06 actually. Okay, let's measure the base of the transistor. and the base of the transistor is, if I'm not mistaken, is this. That's the base. Huh. Ooh, dear, oh dear, oh dear. Minus 4 volts 28. Oh dear, that's really not good. Not good at all. Okay, and just to measure something else, which is this. And the collector is, well, practically dead. It measures 2 millivolts. So minus 2 millivolts. So the collector is dead. Really dead. Okay, so well, what this would suggest to me is that the transistor V3 is shorted between base, or practically so, between base and emitter. Yeah, there's probably a short there. Yeah, and in fact, yeah, well, I'm not quite sure, of course, but seeing it's a PNP, and it is a PNP, no, it's an NPN. It's an NPN transistor. That would tend to say that, well, you know, the base is negatively charged, let's say, and that for a NPN transistor is not good. Well, effectively it switches off the transistor completely. That's for sure. Now, okay, I'm not saying 100% certain that the transistor is dead, but obviously something is really wrong here. Really, really wrong. So, okay, let's just check another transistor to be on the safe side. So, let's switch on the Shortwave Band transistor. And that's transistor V4. Okay, so that's this transistor over there. Okay, so it's this one here. Okay, and we're going to measure the emitter and base of that transistor. Okay. So the emitter should be around 4.2 volts, the base should be 1.9 volts, or thereabouts. Right, so let's measure V4. V4 being this transistor right here. Okay, so V4 is right here, and we're going to measure the emitter and the base. So what did I say? The emitter should be 4.2 volts, the base 1.9, 4.2 and 1.9. Okay, so let's locate that transistor. Where is it? Okay, just to say that I'm a creature of habit like all of us. I didn't read, or rather I didn't realize that this radio is wired differently. Actually, what I would consider ground, okay, is actually the positive, right? So this I marked ground, out of habit, yeah, but when you look closely at the schematic, okay, you'll see, for example, that all the electrolytics, like this one here, okay, are connected with their positive or their anode to ground. Okay, so this one, this is a ground symbol. Okay, and you'll see that the clear box, so an electrolytic symbol is a black stripe, a black full stripe, and a clear box. And a clear box is the positive or anode, whereas the black is the cathode. And if you look at every electrolytic on the schematic, so this one for example, you'll see that the plus is connected to ground, the plus is connected to ground. So actually what I consider ground is positive. Okay, so that explains that. But okay, when I measure the voltages at V3, okay, when I measure the voltages at V3, let me give you some extra good view of it all. So when I measure that, and I measure the emitter of V3, I get this. Mind you, I'm on the long wave band now, so instead of 3.2 volts I get 4.97 volts on the emitter. Okay, and when I measure the base, I get 4.27 volts positive instead of 1.8 volt. Okay, so clearly there is something completely wrong here. Okay, so the voltage on the base is way too high, and the voltage on the emitter is also high, but the weird thing is, it's if you look at the voltage, it's at the emitter, it's 4.97. okay, if you look at the base, you look, it's 4.27. okay, so there's 0.7 volts difference, and that looks suspiciously like the voltage drop, like a voltage drop between base and emitter. Now, yeah, there should be a voltage drop of about 0.6 volts between base and emitter. But so that would be theoretically correct, but the fact remains that the voltage is way too high, way too high at the emitter. So it's almost 1.8 volts too high, and the voltage at the base is certainly way too high, because it should be 1.8 volts, and it is actually 4.27 volts. That is not good. Okay, that's really not good. So what I need to do now is to see whether there's another component bad or not, and if not, then I really suspect V3 of being bad. So let's measure a few other points on the PCB, and we'll have a closer look at V3. I don't know whether I lost a lot because I seem to have lost one video file. But anyway, let me just recap quickly what I did. So I replaced this transistor, which was supposed to be a 2SC829, but turns out to be a Mitsubishi C1359. Now, I don't know whether the two models would have been compatible. I suppose they were. In any case, I took out this transistor, which is transistor V3 on the schematic, and I replaced it by one of these, you know, a BC 547. And I think that will work properly. So I also replaced, or rather installed, a tiny little bridge resistor right over there. I don't know if you can see it, but let me give you a close-up. Okay, you see it right there. So I bridged R18 on the schematic, which was supposed to be a 180K, but turned out to be 220K, and I bridged it with a 1 mega ohm 1/16 watt resistor, this one here. And after doing that, I achieved a resistance of about, I would say 175, 176 kilo ohms. Let me show you. I think you can just about see both the meter and the resistor. So let me show you. So if I measure over the resistance here and here, no, well, okay, it's a bit more. Well, it's actually pretty close to 180 kilo ohms. Okay, so a minute ago I measured, it was 177. Now it's 179 and a half. Okay, I guess, you know, with temperature changes and all that, it might have fluctuated a little bit. Anyway, I soldered that little bridge resistor right there. Okay, so now let's give the radio a try, shall we? Oh, and I also cleaned all the contacts with contact cleaner, and that should help a little bit. So now let's try the FM band and then the AM band. I still need to clean a little bit the buttons because they are sticky and they don't want to stay in place right away. So yeah, and that's a mechanical problem, and I'm not as good a mechanic as I am with electronics. But okay, I think with a little bit more cleaning and all that and lubricating, I can get the switches to work properly. Okay, so this is long wave.
Non, mais ça, je peux l'arrêter, cette collection. Vous me dites, vous avez déjà arrêté 2 fois avec les garçons.
It's a French radio station. One of the very few radio stations I can still get on long wave where I live. Okay, so that's long wave. Now let's go to AM band or medium wave. Yeah, like I said, I still need to clean the contacts a bit.
Camera on the M66 system. It shows the moments after a collision between a lorry and a flatbed.
Okay, so this is an Irish radio station on the AM band. All broadcast. Right, so now let's go to the Shortwave Band. Yeah, well, like I said, the switches don't always work properly, but that's a mechanical problem. Let's go to the FM band first. The radio has plenty of power. And now that I replaced that transistor and the resistor, the radio plays plenty good. Excuse me, if only I could get those switches to work properly. But okay, anyway, that is something for the next episode to do. Right, I cleaned all the buttons, all the band switch buttons, and now they seem to work properly. Now, what I did not show you was actually the result of me repairing or replacing that broken transistor. So you'll remember that when we measured the local oscillator of the AM band, which is transistor V3 on the schematic over there, we did not register any kind of oscillations. Okay, so let me show you now what happens when I measure the frequency of the local oscillator for the AM band, right where I'm holding the probe. Okay, so there's the scope. Okay, now hang on, I'm going to show you what happens when I touch the probe to the AM local oscillator. Okay, so here we go. I'm touching now. There you go. And now I'll be tuning over the AM band. You see? So we're nearly at one end of the tuning band. And now we go back the other way. You'll notice that the oscillations, well, aren't really perfect, are not really perfect, how should I say, sine waves. Okay, so they become a little bit deformed. Okay, I'm going to the other end of the tuning band. Okay, we're nearly there. Oh, yeah. Voila. That's the other end of the AM tuning band. So anyway, what I wanted to show you was that the local oscillator for the AM band does work properly now. With that replaced transistor and that bridged resistor. Okay, so there was one frequency band I had not yet shown you working, and that is the shortwave band. Now, normally we don't get a lot on the shortwave where I live, but there are a few radio stations on the shortwave band. Let me show you. It's very touchy and there's a lot of noise. So yeah, you can receive something on the shortwave band, but it's really bad reception. And okay, let me slide the antenna out. It will help a little bit. Okay, that's with the antenna out. But even with the antenna, it's pretty hard to receive anything on the shortwave band.
Into Radio Romania International broadcasting from Bucharest.
Okay, that's a Romanian radio station. So yeah, okay, you can get a few radio stations on the shortwave band. But I guess more than, say, 3 or 4 stations, forget it. Anyway, the radio seems to work now properly on all the bands. So what's left for me to do is to clean up a little bit the buttons and the dial plate. And then I need to clean up the cabinet, and I still need to restore that. But well, I guess everything which needed to be done to the radio to get it to work again is done. I'm considering giving it an alignment, but I don't know if I want to mess around in this, because you know it's really tight in there, and if I mess up any of these tiny parts, I'm cooked. Okay, so I'll consider it, but consider it as very unlikely that I'll give it an alignment. I prefer not to, but we'll see. Maybe my curiosity will override my reluctance. We'll see for the next episode. Anyway.